The new Corvette ZR1 makes 1,064 horsepower. What the That's more power than Bugatti's new V16 engine. That's over 250 more horses than Lamborghini's new twin-turbo V8 engine. That's more than 1,064 Subaru Crosstreks combined based on what it feels like accelerating in a Subaru Crosstrek. Okay, and one more because I can't help myself. That's more horsepower than the Dodge Demon 170. And the Demon's using stat-boosting ethanol, cheater fuel, while the Corvette is doing it with your trusty old 93 octane pump gas. If none of this has raised your blood pressure, congratulations on living a healthy lifestyle. So let's talk about the Gemini engine. So Gemini is some space reference, and GM did some stuff with space and astronauts like Corvettes. Look, I don't know, just Google it. The point is, Gemini in Latin means twins, and in this case what it is referencing are the LT6 used in the Corvette Z06 and the LT7 used in the Corvette ZR1. Both of them originating from that same flat-plane 5.5-liter engine architecture and then going their different ways as far as a very powerful naturally aspirated engine and a very powerful turbocharged engine. Alright, so as far as the airflow on the Z06 engine, you've got your air coming in from the back, running into your intake manifold, through your cylinders, and out the 421 exhaust. Now on the new engine, we have twin turbochargers, so a turbocharger on each side. So you've got your air coming in, again from the back, routed to that compressor wheel, through an air-to-water intercooler, through your throttle, then into your intake manifold, into your cylinders, and then right out the cylinders for spinning up that turbine for the turbocharger. So as far as what is the same, well, it's sharing that 5.5-liter block. You also have the same valve train layout, and you have the same direct injection system. Now, what is different with this new engine? Well, of course, the big change being twin turbochargers, running about 20 psi of boost in standard conditions. Now, running boost means you're going to want to drop down that compression ratio, so it's been reduced from 12.5 in the LT6 to 9.8 to 1 in the LT7. How do they do this? Well, they've changed the head casting so it has a slightly larger combustion chamber. They've also shortened the connecting rod length, so pulling that piston down a little bit by 4.5 millimeters, enabling a larger combustion chamber and reducing that compression ratio. Of course, because this is a boosted engine, you don't want a lot of valve overlap like you might have with a naturally aspirated engine, so they have changed the cam profile and timing so that you have less valve overlap. They have also improved the internals of this engine, of course, to compensate for all that added power. Now, one interesting and unique thing about this engine versus the LT6 is that you have separate manifolds. So whereas previously you had your intake manifold with these three butterfly valves in the middle, so they were actually linked, now the manifolds are completely separate. So instead of like a V8 acting all as one, it really is two independent four-cylinders, both making 532 horsepower. So pretty bonkers. You've got these two, four-cylinder engines, single turbo, mated to a common crankshaft, same flat plane crank, same firing order, but acting very independently. You also now have port injection as well, because they need a lot more fuel to make all that extra power. This also helps with particulate emissions, and it can reduce noise when you're only running on the port injection. It's not as loud like when you're just sitting there and idling. Now, I know people will rejoice because port injection means no carbon on the intake valves, but every time I ask a powertrain engineer about this, they remain indifferent to the benefit. Consumers worry about it, but internally they don't see negative impacts from carbon on the intake. So yeah, port fuel injection will keep things shiny and clean. On direct injection engines, Corvette engineers say buildup occurs with a mellow drive cycle, but once you ask for performance, you knock it off. So it's really just a visual thing. In other words, if you're buying a direct injection Z06, drive it like you bought a Z06. Oh, and on the subject of vehicle reliability, a big thanks to today's sponsor, Carly, which offers a scanner compatible with OBD2 ports that has a huge variety of features depending on your vehicle make and model. With the basic free version of the app, you can access OBD-level diagnostics to read check engine codes and understand what's wrong with your vehicle. Upgrading to the premium subscription unlocks all kinds of additional features, such as live data or even coding in new features to your car. Personally, I love the live data. Say you're towing and you want to monitor coolant temperature. You can keep a gauge up. Or perhaps you've modified your car and you want to monitor your manifold pressure or timing advance. You can also watch this live, or you can monitor your intake temperatures and discover that your cold air intake is actually a hot air intake. And if you're just buying the scanner, it comes with a 14-day money-back guarantee so that you can check the functionality with your car before committing. You can find a link to the Carly scanner in the video description, and you can use the discount code EXPLAINED for 15% off. Alright, say it with me. Why do we hate turbocharged engines? Turbo lag! Cool. Okay, so what did Corvette engineers do about said turbo lag? Well, several things. First of all, the turbocharger is integrated into the exhaust manifold. So this means a really short distance from those cylinders to that turbine, which is critical because it means you're not losing much energy getting those exhaust gases to that turbo. Then on the intake side, you also want a really short path. So as you can see, it's super direct. It goes straight from the turbo, right up through a small air-to-water intercooler, right through the throttle, right into the intake, right into the cylinders. Very short path. Corvette engineers have seemingly always found a way to take a giant engine and make it look really small. It's a pretty cool achievement here. And so you've got short paths. That's critical from the beginning. But then you can also put in some strategies as far as anti-lag. So this is what the engineers told me they do. When you lift off the throttle, well, the first thing that's going to happen, you're going to cut fuel. You're going to close your throttle, of course, and then you're going to close the wastegate in the turbo. So all the gases that are going through the engine are now passing through the turbo and trying to spool up that turbine. Next, you're going to maintain pressure on the intake side, right? Because this turbocharger is spooling with the airflow that is going through the engine, and it's trying to create some boost on the intake side. On the left side of this throttle here, you're trying to create pressure. And then the second you open up that throttle valve, well, you've got that built-up pressure to go in the engine. Now, you're not using any fuel to do this, so there's not like an obscene amount of airflow going through that engine, right? But there is going to be some airflow, and this is the strategy they're using, which they say helps reduce turbo lag and gets you pressure left of that throttle, and then immediately it's got a very short distance to travel to get into those cylinders. Now, if you were sad because the Z06 had less engine torque than a base C8 Stingray, well, you don't have to be sad any longer, because the ZR1 has 828 pound-feet of torque. And for the rest of the world that doesn't understand what the heck a pound-foot is, hey, don't worry, neither do we. All you have to know is that more is good, and this has more. Alright, so looking at horsepower and torque, it's absolutely absurd. Here we have RPM, here we have horsepower torque, and looking at these here, okay, so light red is Z06 torque, darker red is Z06 horsepower, light blue is ZR1 torque, dark blue ZR1 horsepower. And as you can see, look at this huge shift in the torque curve. So whereas previously from about 3,500 to a little over 8,000, we've got great torque. Well, yeah, we've added 80% on top of that now, from about 3,000 RPM to about 7,000 RPM. Corvette says it has over 800 pound-feet of torque from 3,000 RPM to 6,500 RPM. And at 7,000 RPM, it's something like 798. So really, from 3,000 to 7,000, 800 pound-feet. It's absurd. It's absurd. Now, they did reduce redline slightly, so now in the ZR1 you're only revving to 8,000 RPM versus 8,600 RPM in the Z06, but you've got so much more torque going from 460 to 828, and so much more power going from 670 to 1,064. Almost 400 horsepower added. Now, let's take a moment to chat 0 to 60, because when Corvette moved the engine from in front of the driver to behind the driver, it shifted the weight distribution back, which unleashed the car's potential for accelerating quickly. So on July 24th, 2019, which just so happens to be exactly 5 years ago as of this recording, I predicted the rear-wheel drive C8 platform would have a best case 0 to 60 of 2.76 seconds, if the weight distribution is 40-60. Well, guess what? Car and Driver tested the Z06, the current fastest version of the Corvette C8, and they did a 0 to 60 in about 2.8 seconds. True 0 to 60, no rollout nonsense. Math is cool, it checks out. So another thing that math says is that the Corvette is traction limited in second gear, meaning if you gave the Z06 more power, it wouldn't accelerate to 60 any quicker because it's already at the limit of traction. So I don't really think we're going to see a much better 0 to 60 time for the ZR1 unless it has significantly more weight in the rear or slightly better tires. But I think the tires are going to be pretty similar, so really it's just going to come down to, is there a lot more weight because of these added turbos on those rear wheels? If so, it could have a slightly better 0 to 60 time, but it won't be a huge difference. Again, sometimes you have to see, what do the manufacturers say, what do they not say? And in this case, they're not talking about the ZR1 0 to 60, probably because the E-Ray might have a better 0 to 60. Anyways, what's interesting here, they do share quarter mile under 10 seconds, and they do share an 80 to 200 to 80, because that's what we all care about, 80, 280, I don't know. Doesn't matter. Point is, I don't think it's going to have that much of an improvement on 0 to 60, probably somewhere around 2.7, 2.8 seconds. Now, if you've watched this channel, you've probably heard me say torque doesn't matter, power does. Which is true, like in the context of, you know, nothing really matters. Like, this is just a dude in front of a whiteboard. But torque doesn't matter because you can take advantage of gearing. But it does matter because it represents what you feel. So let's talk about our feelings. All right, some whiteboard therapy. So in order to understand what we feel pressing us back into the seat as we're driving, we need to understand the force that is being applied to the ground by the tire to accelerate that vehicle. Well, we can calculate this using what we know from the engine torque, the transmission ratios, the final drive ratio, some assumed efficiency, as well as what is the radius of your tire. But we need to know the gear ratios of the Corvette. Well, Tremec does provide the gear ratios for the C8 transmission, and GM confirmed the ZR1 does use the exact same gear ratios and same final drive as the Z06, though the gears are physically wider, as in thicker, in order to accommodate the added torque. Alright, so let's calculate what is the force that the tires are pushing against the ground in first gear at peak torque in three different options. The standard C8 Z51, the Corvette Z06, and the Corvette ZR1. And we'll do all of these in first gear, and so for the Z51, that number is about 6,254 pounds of force. In the Z06, you know, much more powerful engine, right? Well, that number is only 6,427, so not much more. What does this mean? Well, it means the feeling of acceleration in the Z06 and the base Stingray is going to be very similar. The difference is the Z06 is going to hold on to that speed for longer, so it's going to go up to a higher speed in second gear. Your second gear is longer. You get that feeling for longer, but it's not really much different as far as what does the feeling feel like as far as acceleration. ZR1 cranks this, all right? 11,569. Nice. So now, what is the maximum amount that we could apply to the ground in first gear and accelerate it without spinning the tires? That number is going to be something like 3,630. So all of these can do burnouts, great. But what matters is as you start to get to higher gears, well, then that number keeps going lower because your gear ratio is lower, and so your acceleration drops. Now, as far as the Z06 holding on to gears for longer, if you're in third gear in the standard C8 Z51, you'll accelerate in third gear up to about 83 miles per hour. In the Z06, you'll have slightly more acceleration that'll be pushing you a little bit more into your seat, but you'll hold on to it much longer in third gear up to 105 miles per hour. So that's why it is a significantly faster car. Again, power playing a role here. Now, in the ZR1, any gear you're in versus the Z06, you get an 80% boost in how much that force is pressing you against the seat, assuming you have the traction to put it down. Absolutely absurd. So some silly stats of the ZR1 versus the Z06. In second gear, the ZR1 has more wheel torque than in first gear in the Z06. In sixth gear in the ZR1, you have a greater force at the tire than you have in fourth gear in the Z06. All right, but here's two more stats that are absolutely ridiculous. First, it has the wheel torque to do a burnout starting in fourth gear. Now, it'd be a bit of a complicated mechanical situation because you need to get the engine revs up high and probably slip that clutch in order to keep that wheel torque really high in order to make it all happen. So it may or may not actually do it, but it has the wheel torque in theory to make that happen. Also, if you were to start an acceleration run from 0 miles per hour in fourth gear, and you were to apply that same strategy where you slip the clutch and you hold the engine at peak torque, it could get a 0 to 60 starting in fourth gear of about 3.1 seconds versus the previous generation ZR1, which does 0 to 60 in 3.2 seconds. In other words, this car starting in fourth gear in theory could be quicker than the last generation ZR1. Absolutely bonkers how fast this thing is going to be. Okay, but a quick comment, because if for some reason from this video you got the impression that combustion engines are rad and EVs are boring, well, consider this. The ZR1 has deleted the Corvette's frunk in order to accommodate the increased cooling requirement of the new potent engine. No frunk? Pfft. All right, I'm out. If you have any questions or comments, feel free to leave them below. Thanks for watching.